Okay, so let's discuss about the linked list data structure today. Okay, so we'll try to understand how we are going to add the element or how we are going to add the object, okay, into one linked list collection. Okay, so basically suppose let's say suppose let's say I'm having some element, let's say 10, 20, 30 and 40. Okay, so these are the integer object or integer value I want to add in one linked list collection. Okay, so then how we can add into the linked list collection? So as part of this Java API, we are using the collection framework, right? So as part of this collection framework, so there is one class is there. There is a class is there, linked list. Okay, suppose let's say I'll write here class test. Okay, so then how we can add this element? Public static void main method. We need to create one linked list class object. Okay, how we can create linked list? Okay, so what type of data we are going to add it? Integer. L is equals to new linked list. Okay, so now what we have defined here? So we have created one linked list object. Okay, so here as part of this piece of code, one linked list object got created with the reference variable as L. Now how we are going to add this element to this linked list object? So by calling the add method, L dot add of 10, L dot add of 20, L dot add of 30 and L dot add of 40. If we'll try to print here system.out.println of L, so what will be my output here? The output will be 10, 20, 30 and 40. So as this linked list is an implementation class for the list interface, right? And we know like list in case of list, the insertion order will be preserved. In which way we are inserting, based on that only it will be the element or the object will be inserted into the corresponding list object. Okay, so that means to this L object you are adding 10, 20, 30 and 40. Okay, so now let's try to understand how internally this object is going to store in case of linked list. Okay, so basically we'll try to understand how this linked list data structure is working internally. Okay, so basically we are storing or we are structuring this data based on the linked list data structure. Okay, so let's try to understand how this linked list is working internally. Okay, so now suppose let's say I want to add certain elements. Suppose let's say I am having 10, 20, 30 and 40. Okay, so these four integer value I want to store in one linked list. Okay, by following the linked list data structure. Okay, so in case of linked list data structure, okay, so what we need to consider, each and every element we will need to consider as one node. Okay, so this for this 10, so this we need to consider like each and every element will be stored in one node. Okay, what do you mean by node? A node will consist of two parts. Okay, the first part it will consist of data. This first part it will store the data. Okay, so what I told, for each and every element it will create one node object or not? Okay, 10, 20, 30 and 40. Okay, so for each element we need to create or it will be created one node object, it will be created. Okay, so in a node how many parts will be there? So there are basically two parts will be there. The first part is it will store this data, okay, and the second part is it will hold the address reference of the next node, okay. So this node will hold this part, it will hold the address reference of the next node, okay. So similarly, as this is also one node, it will also hold the address reference of the next node, okay. So then again this part it will again hold the address reference of the next node, okay. So this is like one node is or one object or one value. So you will see here all the elements are linked with each other or none. So that's why this is called linked list data structure, okay. One node is linked with another node, okay. So one node it will hold the address reference of the next node, and this node again it will hold the address reference of the next node, and this node again hold the address reference of the next node, okay. So each and every node will hold the next address reference of the next node. So that means all the elements are linked with each other. So that's why this concept we are calling it as linked list data structure, okay. So as part of this linked list data structure, we need to consider all the elements as one node format, okay. So this is the first node or node, okay. So in case of linked list, this first node itself we are calling it as which node? Head node, okay. So the first element or the first node of a linked list we are considering like it is a head node, okay. And the last element we are considering as, or we are calling this one as tail node, okay. So if you'll observe here, so this is the head node or not. So as part of this head node, this head node is holding the address reference of the next node, okay. Again this node is holding the address reference of the next node, again this node is holding the address reference of the next node, but this tail node is not holding any other node, right? So that means this part is as it is not holding any other object node object. So that's why this part is nothing but null only, okay. So then how we can identify who is my tail node? So whose next value is null, okay. So this is the node that it is not holding to any other address reference of the next node. So that means this value is null only, okay. So for example, let's say there are few person are standing, okay, and let's say they stand by holding their hand, okay. So that means they are linked with each other or not, okay. Suppose in this case I want to add one more element here. So what will happen? So I need to traverse from the head node to the tail node or not. And how we can find out like who is the tail node? Whose next value is null, okay. So we need to, for this 50 again, we need to create one node object or not. So we need to create one value called 50, okay. And this 40 instead of null, now this part again it will refer to the next node, okay. Now this 40 will hold the address reference of the next node, that is nothing but 50. So now who is your tail node now? Now your 50 is nothing but your tail node, and as this 50 is not holding to any other node, so that means this part will be considered as null, okay. And this now this 50 is nothing but tail node only, okay. So I hope you are clear. So now in this case, if you will see here, let's say 4 people are standing, okay, by holding their hands, right? So that means all the 4 people are linked with each other or not. So now let's say I am coming and I want to stand along with them. So that means what we need to do? Okay, so first of all I need to check here. Are you holding to anyone? Yes. Then I need to go to the next person. Are you holding to anyone? Yes. Then I need to go to the next person. Are you holding to anyone? Yes. Then I need to go to the next person. Then I need to check, this guy is holding to anyone? No, he is not holding to anyone. So then I need to go to here and I need to stand here and I need to hold his hand. So that means who is the next person of this guy? I am the only one who is the next person of this guy only. So but now I am not holding to anyone. Okay, so if any other new person will come, then again this person will come here. Okay, so this is how this linked list work. Okay, so linked list means all the element will be linked with each other. Okay, for each and every element will be considered as one node. Okay, and one node will have the two parts. One will consider or one will contains data, and the second part it will hold the address reference of the next node. Okay, so this is nothing but linked list. Okay, so now suppose let's say I have certain elements are there. Okay, 10, 20, 30 and 40. Okay, I want to add this 4 integer value into one linked list by following the linked list data structure. Okay, so then how we can store the record? What I told, for each and every element or for each and every object, so there should be one node object should be created or not? Okay, so now one node is having how many parts? 2 parts. One will contains the data and the other part will contains the address reference of the next node. So similarly, this node will contains data as 20 and this part it will hold the address reference of the next node. So similarly, this node will contains 30 and it will hold the address reference of the next node. Similarly, here it will be 40 and as it is and there is no other element, right? So what will be the value for this next part? Null. Okay, so this part we are calling it as head node. Okay, and this part we are calling it as tail node. Okay, so if you will see here, one node is linked with another node or not. So that means from if I got the head node, so then I can traverse to the next node onwards or not. So that means if I will find this head node, I want to find the next node. So then what we need to do? We need to go to the next address reference or not. So now we will get the next node is nothing but 20. Again I want to check, let's say, who is your next element or next node. Then again I will get the 30 or not. Suppose for example I want to get who is the previous element or previous node for this 30. Am I capturing or am I holding the address reference, any address reference of the previous node? No, right? So in this case only we are storing the address reference of the next node. Okay, so that means it is nothing but this type of linked list we are calling it as single linked list. Okay, so single linked list means so one node will hold the address reference of the next node only. Okay, so this node will not hold any address reference of the previous node. So there is no in this node does not have any information about the previous node. Okay, so then this type of linked list we are calling it as single linked list. Okay, suppose let's say I want to track or I want to hold the address reference of the previous node. So then how we can do it? So then for each element we need to create a node. Okay, so now in this case, okay, this node will contains 3 parts. Okay, each and every node will contains 3 parts. Okay, now the middle part we need to store the data 10, 20, 30 and 40. Okay, so now this is one node or not, and who is the next node of this 10 node? The 20 or not. So now this part it will hold the address reference of the next node. Okay, Similarly, this node will hold the address reference of the next node. This node, this part, it will hold the address reference of the next node. And here, what is the value for the next part? It is null, because there is no other element or any other nodes are there. Similarly, for this 20, who is the previous node? This part will hold the address reference of the previous node. Okay. Similarly, this part, it will hold the address reference of the previous node. Similarly, this part, it will hold the address reference of the previous node. So that means if you will see here, now I can track from, like, I can go, once I will get the head node, I can find the next node, and for this node I can find the next node or not. Similarly, for this node I can again find the who is the previous node. Okay, so this type of linked list we are calling it as double linked list. Okay, so in case of single linked list, only we are holding the address reference of the next node, but in case of double linked list, we are storing the address reference of the next node, and also we are storing, or we are holding the address reference of the previous node also. So this type of linked list we are calling it as double linked list. Okay, suppose let's say I am creating another type of linked list where this part is 10, this part is considered as 20, this node is nothing but 30, this node is nothing but, let's say, 40. Okay, so in this case, if you see here, now this 10 is holding, this part is holding the address reference of the next node or not. Similarly, this 20 is holding the address reference of the next node, 30 is holding the address reference of the next node. Okay, similarly, this 20 is holding the address reference of the previous node. Okay, 30 is holding the address reference of the previous node, and this part is holding the address reference of the previous node. Okay, so in this case also, if you will consider, in case of double linked list, okay, so who is the next node? 20. Who is the next node? 30. Who is the next node? 40. Who is the next node? There is no next node, right? So what is the next value here? Null. Okay, so similarly, for this 10 node, who is the previous node? Is there this guy is holding any other previous node? No, right? So then this value will be considered as null. Okay, but in this case, if you'll see here, what I want to do, this 10 is holding the address reference of this 20, this 20 is holding the next address reference of the 30, this 30 is holding the address reference of the 40. Now what I want to do, this is the tail node or not? I want to hold, this tail node should hold the address reference of the head node, let's say. So then this type of linked list we are calling it as circular linked list. Okay, so in case of circular linked list, okay, so the tail node will hold the address reference of the head node. Okay, so this type of linked list we are calling it as circular linked list. Okay, for example, you have, suppose let's say some music application is there, okay, and you are having list of songs are there. Okay, now you are playing some song. Okay, so how will play the song? This is the play button, this is the forward button, and this is the backward button or not. So now the current song is going on. Okay, so now if you play this song, now let's say the current song is going on. Okay, now if you click on this one, then what will happen? The next song will be played or not. So similarly, if you play again, so then next song will be played or not. So that means if you see here, and similarly, if you don't like the current song, let's say, then what you can do? You can click this previous song or not. So that means this is nothing but your double linked list. Okay, so it will be play this song. Then once it is completed, it will play this song. Once it is completed, again this song will be played. Okay, if you don't like this song, okay, again you want to go back, then you click on this previous button, then again it will go to the previous song. Okay, similarly, one scenario is that let's say all the song got completed. Okay, so once all the song got completed, then what you want to do again? You want to replay it from the initial, let's say. So this is nothing but your circular linked list. Hope you are clear. So how many types of linked list are there? Single linked list, double linked list, and circular linked list. In case of single linked list, only we can, like, one node will hold the address reference of the next node. In case of double linked list, we can this node will hold the address reference of the next node. This node will hold the address reference of the next node. Similarly, this node will hold the previous response of the previous address reference of the, sorry, it will hold the address reference of the previous node also. So that means one node, through one node we can track the next address reference, and we can also track the address reference of the previous node also. Okay, so this is nothing but type of linked list we are having. Okay, so now let's try to understand why we are using the linked list and in which scenario we need to use the linked list. Okay, so in order to store some element, or object, we are having one implementation class is there or not? What is that class? Array list. Okay, by using this array list implementation class, what we can do, we can add the element or add some integer value, let's say. Okay, so similarly, now we are having another data structure or not? Okay, so what do you mean by data structure? In which structure we are storing the data, so that it will be easy for manage. Okay, it will be easy to manage. Okay, so that's why this is nothing but data structure. So this is one type of data structure, this is another type of data structure. Okay, so in which scenario we need to think I need to use the array list, or in which scenario we need to think we need to go for linked list. So let's try to understand. So in case of array list, how this element will be stored, or how this object will be stored? In case of index format. Okay, so in case of array list, all the object or element or value, it will be stored in a index format. Okay, so 0, 1, 2, 3, 4 and 5. But in case of linked list, how the element will be stored? In a node format. Okay, so this is one node, 10, 20, 30, and here let's say 40. Okay, so now this node will hold the address reference of this node, this node will hold the address reference of this node, okay, and this node will hold the address reference of this node. Okay, so now in which scenario we need to go for array list, and in which scenario we need to go for linked list. Okay, see, suppose let's say my frequent operation is searching operation, I want to perform the searching operation. Okay, so then it is best choice to go for array list. Why? Because all the element is stored based on the index value or not. If I write here L dot get of 3, then I will get the value as 40, right? So based on this index value, I am able to search, or I am able to retrieve this value 40 or not. So that means if my frequent operation is retrieval operation or searching operation or fetch operation, then we need to go for array list. As array list internally store the record based upon the index format. Okay, by using those index, we can find out the corresponding value. Okay, so that's why if our frequent operation is searching operation, then we need to go for array list. Okay, but similarly, let's say I want to do the same operation in case of linked list. Okay, so then what will be happen? Suppose let's say I want to find out this 30. Okay, so then how we are going to find out this 30 element? We don't know about any node, we know only head node. Okay, so first of all I need to go to the head node, I need to check hey, are you 30? No, I am not 30. Then I will traverse to the next node. I need to check, are you 30? No. So then I need to go to the next node. Are you 30? Yes. So in order to find or in order to search this element, so I need to traverse each and every node or not. So where it will take some time taking. Okay, it will be time taking process. If my frequent operation is searching operation, or if my frequent operation is retrieval operation, so it is best choice for going for the array list instead of linked list. Okay, because if we go for linked list means we need to traverse each and every node in order to find the exact element, okay, or exact object. So that's why linked list is not good choice if we are doing the searching operation. Okay, so that's why array list is the best choice in case of searching operation. Okay, so then when we need to go for linked list, then instead of array list, suppose let's say here some element I am adding, right? So now let's say I want to add 35. Okay, where I want to add this 35? After 30 I want to add the 35. So that means on this third index I want to keep the 35, let's say, or let's say I want to insert, let's say, 15 in this array list. How we are going to, where I need to store this 15? After this 10 I need to store this 15 or not? So that means in place of 20 or in first index I need to store this 15, right? So if I will store this 15 in the first index, okay, so that means I need to store the 15 here. And this 20, what we need to do? We need to shift this 20 to the next index. Okay, so that means this 20 will be shifted to the next index, 20 here. Then 30 will be shifted to the or moved to the next index. Okay, so here it should be 30. Then 40 will be shifted to the next index, 40. Then 50 will be shifted to the next index. Here it will be 50. Now 60 will be moved to the sixth index. Okay, so if you see here, in order to perform the insertion operation, so what we are performing here or what we are doing here, we are shifting almost all the index value. Okay, so whatever the value it is present in this index, we need to shift from the next index onwards. Okay, so that's why if I want to insert one element, so I am shifting every element or not. Okay, so that's why it will take lot of time to insert the operation if we are performing the insertion operation. So that's why if our frequent operation is insertion or update or deletion operation, similarly, suppose let's say I want to delete, then again we need to shift this index value again or not to the previous index. So that's why if my frequent operation is insertion or deletion operation or any kind of update operation, we should not go for this array list. Okay, we supposed to go for linked list. Why? Suppose let's say I want to add 25 here. Then how we can add this 25 here? So for this 25 we need to define one node or not. So here we are defining one node called 25. For this 25 element, we are adding one node here. Okay, so now where this 25 I want to insert? In between 20 and 30. So what we can do? So just without touching any other node, just remove the reference from the 20. Okay, the next part of this 20 will be pointing to this 25, and 25 will point to the 30. Okay, so if you will see here, I am not touching 10 and 40, but still I am able to insert the element or not by just change the address reference. Now 20 will, who is the address reference of this, next address reference of this 20? I am pointing to the 25, and 25 again the next part it will be pointing to the 30. So that's why, so in case of insertion or deletion operation, the linked list is the best way. Suppose let's say I want to delete 20. So then what we need to do? If I would want to delete 20 here, so now 10 will be pointing to 25. Okay, and how this 25 is pointing to this 30? It will be the same way. Okay, so that means without touching any other node or any other element, we are performing the insertion or deletion operation easily or not. So that's why when this linked list is the best choice, if our frequent operation is some insertion or deletion operation, then we need to go for linked list. Okay, so when we need to go for array list, if our frequent operation is searching operation, then the array list is the best choice. Okay, so when we need to go for linked list, so if we want to perform the some insertion or deletion operation, then we need to go for linked list. Okay. Okay, so up to this I hope it is clear. Okay, so now let's try to understand how internally it is working, or let's say I need to write, okay, how to create our own custom linked list class. Okay, so instead of using Java provided linked list class in order to store the or in order to add the element, I need to create my own custom linked list class. Suppose let's say, what I mean, I am having a class test. Okay, I want to add certain object integer value, let's say 10, 20, 30 and 40. So then how we can add into the linked list class? Public static void main method. Okay, so then how we can add this element to this linked list class? So we need to create the linked list class object. So linked list L is equals to new linked list. Okay, L dot add of 10, L dot add of 20, L dot add of 30. Like this we need to add or not. And this, if you see here, this linked list is a class that I am using from the Java class only. So we need to import here, import java dot util dot star, right? So that means this linked list or java dot util dot linked list here. Okay, so if you see here, this linked list I am using from the Java package or not. So that's what I am telling. I'm trying to explain. Instead of using this Java provided linked list class, I want to write my own custom linked list class, and I want to insert the element based on by following the linked list data structure. Okay, so how we have understood the like node format, right? The same way we need to implement practically. Okay, okay. Okay, so suppose let's say my requirement is I want to add certain elements, let's say 10, 20, 30 and 40. I want to add this integer value to the list object. Which list object? My own custom linked list class object. Okay, so that means I need to write my own linked list class, and by using that linked list I need to add this element. Okay, so let's try to understand. So suppose let's say I'm writing here class test, public static void main method. Okay, now I want to add this element. How we can add this element? Okay, so what is our main fundamental, what we understood? For each and every element we need to have one node object or not, right? So for this 10 I need to create one node object here. Okay, for this 20 again I need to create one node object. For this 30 again we need to create one node object. For 40 again we need to create one node object or not. So okay, now so for each and every element we need to create one node object. Okay, so as this is the first element, let's say 10. For this 10 I need to create one node object or not. And a node object contains or consists of how many parts? two parts. One will hold the data. What is the data here? 10. And the another part, it will hold the address reference of the next node or not. Okay, so that means this part is nothing but next. Okay, so who is the next node? Okay, so that means that's why I am defining one. So how many parts will be there in one node? There will be two parts will be there. One will be data, another part will be next. Okay, so that's why we need to write into the Java. Okay, so as we know, like Java is an object oriented programming language, right? So everything we need to consider as one object. Okay, so as this is one node and we want to implement in Java, so we need to consider this node as one object. Okay, so then how we can represent this node in one object format? So we need to write one class here. Okay, class node. Okay, because we need to represent this as object or not, and how we can represent this as an object? We need to write the corresponding class. Okay, so class node. One node is having how many attributes or how many properties it should have? One will be data and one will be next. Okay, so that means how many attributes it will be having? One will be data and another part will be next. Okay, you will see here, as part of this data, which type of value I am storing, integer type of value or not. So that means I am defining here int data. You will see here, this next is holding another node object or not. This is again a node object or not. So that's why what should be the type of this value or variable? It should be node type. Okay, because this next is a variable which is holding again another node object. So what should be the type of this variable again? It should have node. Okay, so now I need to write one constructor here in order to create the object. Okay, node of int data. Okay, this dot data is equals to data. So here I am trying to initialize this node object by using the data only, not by using next also. Okay, so we need to initialize or we need to create the node object by using data only. Okay, not next. Okay, why? I will explain later. Okay, so up to this I hope it is clear. So what I am trying to do here, this node representation, okay, I am defining as a class format. Class node. One node will have two attributes or two parts. One will contains data, the another part will nothing but it will refers to the address reference of the next node. So that's why I am defining two variable, data and next. Okay, int data node next. Why it is node type? Because this node next value or next it is holding, next variable it is holding another node object itself. So that's why it should be node type only. Okay, so now we need to add the element or add the object to our custom linked list. Okay, so that means in order to add this element or in order to add this node or element, we need to have our own custom linked list class or not. So let's write our own custom linked list class. Okay, so let's say class, let's I'm giving the name as linked list. Okay, I'm defining my own class here as there is no space. I'm not giving the name as custom linked list. You can define any name. Okay, you can define this class name as anything. Okay, class linked list I'm defining, let's say, and this is not Java provided linked list class. It is my own linked list class I want to define. Okay, so now I have defined one class called linked list. So now we need to add this element to this linked list by following the linked list data structure. Okay, so then what we need to do? Now we need to create which class object? Linked list. L is equals to new linked list. Okay, so this is nothing but our custom linked list that I have created. Okay, so now to this linked list, So with this line, what will happen? One linked list object will get created or not? Okay. What should be the reference variable? L. Okay. Now to this element, what we need to do? We need to add the 10 value. How we can add this 10? L dot add. We need to pass 10 or not? So that means if we'll see here, which class object I am creating here? This linked list class object I am creating here. Okay. Now I am calling which method? Add method. So that means which class add method will be called? This class add method will be called or not? So let me define the add method over here. Okay. How we need to define here? Public void add method. Okay. And this add method, it is taking some integer value or not? So let me give the input parameter as int data. Okay. So then I need to write some logic through which this element will be added to this linked list. Okay. So if you see here, every linked list, so suppose let's say there is one linked list is there. Okay. Suppose let's say 10, 20, 30. Okay. So there are some linked list is there, let's say. So every linked list should have one head node or not? Every linked list should have one head node. Okay. So let's say there is two nodes are there. So that means still there is a head node is there or not? Even though let's say there is only one node is there. So that means this node will be considered as one head node only. Okay. If there is no node is considered, no node is there. So that means this head is nothing but null or not, because there is no node is there. Okay. So that's why, but as we are creating this linked list and we are trying to insert some element to this linked list. So that's why every linked list, if any element is there, so this linked list should have one head node or not. So that's why I need to define one property for this linked list, which is nothing but node head, because every linked list has a head node. Okay. I'm defining the attribute name as head. Okay. Okay. So now I have defined a variable or attribute called node head. Okay. So now I need to call the add method in order to insert the element. Okay. So whenever I will try to insert the element, okay, see which method I need to call, then L dot add. Okay. Okay, concentrate here. Let me explain. So now if you'll see here, I'm trying to execute, let's say, linked list L is equals to new linked list. So that means what will happen? One linked list class object will be created or not? So here, so one linked list class object will be created, and what should be the reference variable here? L. Okay. Linked list L is equals to new linked list. So that means I am creating one linked list object or not? So what we know, whenever we are creating one object, this instance variable, the copy of this instance variable, it will be stored inside the linked list object or not? So that means for this linked list, what should be the head value? Initially, this head value will be, the value of this head, it will be null, right? Because at the very initial, there is no value or there is no element is there. So that means head value will be null or not. So that means whenever I am creating this linked list object, so this head value is null. Okay. Now I am trying to add the element L dot add of 10. So what will happen? This add method will be called here. Okay. So while calling this add method, what is the data that I am passing here? What is the data here? It is nothing but 10. Okay. And what we understood, for each and every data, okay, or for each and every element or for each and every object, what we need to do? We need to create one node object or not. So how we are going to create a node object? So I am creating one node object called, let's say, node, new node is equals to, let's say, node, new node is equals to new node. Okay, with this data, okay, I'm trying to create one node object. Okay, so with this line, so what will happen? One node object got created. Okay, one node object got created with which variable? New node. Okay, with which variable it got created? New node. Okay, so if you see here, now I am creating one node object with this data only or not? See, try to understand. Whenever I am trying to insert the element, so now for each and every element there is one node will be there or not? So now let's say 10 I am trying to add, but do I know who is the next node? I don't know, right? Because until and unless I am not adding here L dot add of 20, I don't know who is the next node, right? So as of now, let's say it is executing L dot add of 10. So it will create one node object. So this node object should be created with this data only, right? Because I don't know who is the next. So as we don't know who is in the next value, so then we should not initialize this next value. So that's why I have written one constructor here with the data only. We need to initialize this node object with this data only. I don't know who is the next value, right? So that's why this next value should be null only, because I don't know who is the next value here. So that's why the next part should be null only, and this part should be having some data only like 10. Okay, so that means we need to create one node object with this value like 10, and who is the next value? It should be null only, because I don't know who is the next node. Okay, similarly whenever I call this L dot add of 20, so similarly another node will be created with 20 value or not. So at this time again this node should be created with this data only 20 only, but I don't know who is the next node until and unless I'm not writing here L dot add of 30, right? So that's why this node should be initialized with only data. We should not initialize the next value. It should be null only. Okay, so that's why I have written here a constructor with the data. Okay, so in this case, so what will happen? I am calling the L dot add. For the first time, let's say I am calling here L dot add. So what will happen? This add method will be called. Okay, and what I am passing here? I am passing some data. So which data I am passing here? I am passing the 10 data or not? So now with this data, what I am doing here? I am creating one node object. Node, new node is equals to new node of this data. So that means this new node object got created. What should be the data value here? So data is nothing but 10, and what should be the next value? Am I initializing any next value here? No, right? So what will be the value here? Next is equals to null, because I am not initializing. What is the default value for this next? It is null only. So that's why this node object will be created with data is equal to 10 and next is equals to null. Okay, so now we have created this node object. Okay, now we need to check. Okay, so this is the first element that I am adding or not? 10 I am adding. So that means I need to check here if head equals to null or not. Okay, so if head is equals to null, so that means head is not pointing to any other node, right? So that means there is no element till now there is no element added into this linked list, right? So that means this 10 is nothing but it is the first node. Okay, so if it is the first node, so that means it should be considered as the head node only, right? So that's why what I am writing here, if head is equals to null means, so that means if head equals to null means, so this node is not nothing but this new node that I have created, right? This head should be this new node. Okay, so what I need to write here, if head is equals to null, so then what we need to write here? So then head is equals to new node. Okay, so this head is nothing but new node. So that means now instead of null, now this head is pointing to which object? This new node object. So now this head is nothing but your new node. Okay, so that means in case of, let's say if head is equals to null means, so that means this is the first node. Okay, if it is first node, so that means we need to define here head is equals to new node. So that new node that we have created here, so this we need to point this head to this new node. Okay, so now head, instead of head is not null now, because instead of null we are assigning head is nothing but this new node. Okay, so this is one scenario. Okay, if it is the first node. Okay, suppose now consider, okay, let's come to the second part. As of now, let's consider, okay, L dot, we have written, let's say 20 here. Okay, now in case of I'm adding, let's say L dot add of 20. So what will happen again? So this add method I'm calling a null. So now this add method will be called again. And what should be the data here? The data will be 20 here. Okay, now this time what should be the data here? 20. Now with this data, what we need to do? We need to create one new node object again. Okay, so with this 20, again we have created the new node object or not? With this 20 data, we have created one new node. Okay, by initializing only with data value. Okay, so now in this case, what should be the data now? So data is nothing but 20. But what should be the next value here? Next is nothing but your null. Clear? Because I am trying to create this node object by initializing only data. Now what I am checking here, head equals to null or not. Okay, now if you'll see here, is head is equals to null here? Head is not null, right? Because head is pointing to some other node now, because head is not null. So that means this if block will not be executed. So we need to write the else block. Okay, because head is not null now, because head is pointing to another node object. Okay, so now, so that's why we need to write some else condition. Okay, as of now, let's consider, okay, for example, as of now, just consider we have written some piece of code. Okay, so due to which I am able to add this 20, L dot add of 30. Let's say already this value got inserted. Okay, I will explain how I need to add this 40. So then you will be able to understand how this 20 and 30 got inserted. Okay, as of now, consider, suppose let's say I have written some piece of code due to which this element got added. Okay, data is equal to 20, and for this 30 we have created one node object with data 30. Here what will be the next value? Null. Okay, so now in case of this 20, now next value instead of null, it will be pointing to this object or not? Okay, so as of now, just consider we have written some piece of code in the else block, due to which I am able to add 20 and 30. Okay, I will explain how I am adding the 40. Okay, then you will be able to understand how this 20 and 30 got inserted. Okay, so let me try to add 40. Okay, let's say I am writing here L dot add of 40. Okay, now this line I am trying to execute. Okay, now I am trying to execute L dot add of 40. Okay, so then what will happen? So now what will happen? I am trying to call here add method on this linked list class object or not. So then this add method will be called. Okay, so whenever this add method will be called, what is the data I am passing here? I am passing here 40 is the data that I am passing here. So that means what should be the data here? The data is nothing but 40 here. Now with this data, I need to create a new node object again. Okay, so I have created here one object. Okay, so data is nothing but 40, and what should be the next value here now? Next is nothing but null. Okay, so now if you'll see here, whenever I'm calling the add method, right? Now I am with this data only, I have created one new node object. I have created one node object. So this node object got created with the data as 40. Okay, now this node object should be added after this 30 or not. So that means the next part of this 30 node, it should point to this node. Then how we need to write the logic so that this node should point, the address reference of this next node, it should point to this 40 node. Okay, so let's try to understand. Now we are in this line, node new node equal to new node of data. So with this 40, we have created the new node object. Okay, so this is nothing but new node or not. Okay, so this is nothing but new node, which is nothing but this node only. Okay, now it will check if head is equals to null or not. Now head is equals to null or head is pointing to some other node only. So head is pointing to some other node or not. Okay, so now then how we can write? Okay, so this 10 is pointing to this node, right? Okay, so then how we can traverse from one node to another node in order to reach to this tail node. Okay, so now as this is not the first node, because head is not null, head equals to null, as you are checking here, head is not null, head is pointing to any another node, right? So that means your else, it will come to your else block. So in this else block, what I'm writing here, okay, what I'm writing here, I need to define one node type object, okay, which is nothing but n. Okay, so what I need to define, I need to point this n is nothing but this node. Okay, and we need to check. Now if you see here, this n is pointing to which node? This node or not? And I need to check for this node, what is the next value? Is it null or it is pointing to some other node? It is pointing to some other node or not? Because this is the next node for this 10. So what I did here, I have defined one pointer here. Okay, let's consider pointer. I have defined a pointer called, let's say, n. Okay, I have defined one pointer called n. So what this n is point to, whom it is pointing to this node, let's say. Okay, so that means for this node I need to check what is your next value. Is it null? If it is not null, then who is your next value? So now this is the next value or not? If it is the next value, then this n I need to point it to this node object. Okay, then again, now this, who is the n now? This n is pointing to which node object now? This node object or not? Again I need to check n next. Is it null or it is pointing to any other node? It is pointing to other node or not? So now what we need to do? Again n will point to this node. Okay, now what we need to do? Again I need to check n, for this n, what is the next value? It is null or not? If it is null, then assign this next to this new node. Okay, so let's try to implement this type of this logic, so that if I'll write the code, we'll be able to get clear picture. Okay, so then what we need to define here, I need to define, or I need to point this node through a node value, let's say n. Okay, and this node is nothing but which node? This is nothing but head node or not? Because head is pointing to this node only, right? So I can write here node n is equals to head. So if I write here node n is equals to head, so that means head is pointing to which node? Head is pointing to this node or not? So as n is pointing to, as head is pointing to this node, So that means I'm writing here n is equals to head. So that means n is also pointing to this node or not? Because head is nothing but this node. So that means n is also is nothing but this node or not? Because I'm writing here n is equals to head. Okay, what is head? That is also n. We're able to suppose, let's say I'm defining here int. Okay, I'm defining, let's say x is pointing to 10, and I'm writing here x is equals to y. So that means y is also pointing to 10 value or not? Okay, if I'm writing here y is equals to x, so that means x is, I'm defining here x is equals to 10 and x is equals to, or let's say y is equals to x here. So that means x is equal to 10 means x is pointing to 10, and what I'm writing in the next line, y is equals to x. So that means y is also pointing to 10 value or not? Both the variables are pointing to same 10 value. So similarly, like this, I'm writing here n is equals to head. So what is head? Head is nothing but this node only. Okay, so that's why n is now pointing to this node. As I'm writing here n is equals to head. So that means what is head, that is also n. To which node object this head is pointing to, this n is also pointing to the same node or node only. Okay, so now I need to check here, while n dot next not equals to null. Okay, until and unless n dot next is equal, it is not null, I need to traverse this n to one node after another node. Okay, then how we can traverse it? Okay, how we can traverse it? See, now what I am doing here, first of all, what I did, node n is equals to head. So that means I have created one n variable, that n is pointing to the n is pointing to the same node object to whom this head is pointing, because head is equals to n. Okay, so that's why n is also pointing to same node object. So that means n is nothing but this node object only. Okay, now I am checking n dot next is equals to null. If you'll see here, n dot next is equals to null. No, right? If it is not null, then insert to the while loop. Okay, so that means n dot next, it is not null. Okay, it is because it is pointing to some other node. Okay, so that's if you'll see here, n dot next, it is not null because it is pointing to some other node. Okay, so that's why what will happen, it will be inserted to the while loop, because this condition got satisfied. N dot next is not null. So if it is not null, then what is the next node? Because I need to find out this node, right? To point this n to this node, right? So if n dot next is not null, so then this next is pointing to which node? Okay, then how we can get it? We can write here, if you'll see here, if I'm writing here n dot next, okay, n dot next, it will give me another node object or not? This is nothing but next node or not? So I can write here node next node is equals to n dot next. Okay, if you see here, n dot next is nothing but next node. If I am calling here n dot next, if I am calling here n dot next, it is giving me this node object or not? Because n dot next, it is pointing to this node object. So then I will get this node object. Okay, so I will get here next node object. Okay, so once I will get the next node object, okay, see, suppose let's say if I will write here n dot data, right? So n dot data, so what value I will get here? 10 value I will get here, not? So if you will write here int value, let's say, is equals to n dot data. So n dot data, it will return me this 10 value or not? So that means what is the b? B is nothing but which value? 10 only or not? So similarly, n dot next, it will return me this node object or not? So that's why I'm holding one reference variable. Okay, so now I got this next node value. If it is next, once I got this next node value, what I need to do, I need to point again this n to this next node. Okay, so how we need to write here? Then n is nothing but n is equals to next node. Okay, so what I check here, again I'm telling here what I did, node n is equals to head. So that means what is head? That is also n. So head is pointing to this node object. So similarly n is also pointing to this node object. In the while loop, what I am checking here, n dot next not equals to null. N dot next, is it null? No, it is not null. So that means this condition got satisfied, right? Then it will be reached into the while loop. It will come to the while loop. In the while loop, what I am writing here, I am trying to find who is the next node. If n dot next is not null, then what is the next node? So that's why I am writing here next node is equals to n dot next. So n dot next, it will give me this node. Okay, so that means I got this next node. So once I got this next node, what I am doing here, n is equals to next node. Okay, so now n will be pointing to this next node. Okay, so now n will be pointing to this next node. Okay, then once this piece of code is got completed, then what will happen? Again this while loop will be executed or not. So in the while loop, again what I am checking here, n dot next. Now what is n? Now n is pointing to which node? N is pointing to this node object or not. So that's why what it will be there, n dot next is it null? It is not null because it is pointing to another node object only. So that's why it will check again the condition, n dot next, is it null? It is not null. So that means n dot next is not null. So that means this condition got satisfied. Then it will be inserted into the while loop. Okay, so inside the while loop, again what you need to do, what you are doing here, next node is equals to n dot next. So n dot next, it is giving me the next node object or not. So that's why what n dot next, if I am calling here, n dot next, if I am calling here, I am getting this next node object or not. This next node object I am holding in one reference variable. So that means this next node object is nothing but this next node object or not. So once I got this next node, so then what I am doing here, n is equals to n is equals to next node. So that means I am defining here again, n is equals to next node. So now n is not pointing to this node. What I am writing here, n is nothing but next node. Who is the next node? This is the next node. N is equals to next node. Again it will goes to the while loop. Again what I am checking here, n dot next is not equals to null or not. Now it will check n dot next is equals to null or not. So now this condition got failed because here I am checking for the not null, because but here what I got the null value. So now n dot next is equals to null. So then it will come out from this while loop. Okay, so because this condition got failed. Okay, because n dot next is equals to null now. Okay, if it is null, then what you need to do, then if n dot next is equals to null or not. If it is null, so then n dot next, the value should be this node or not. This n dot next is equals to null now. Okay, so what we need to define, this next should point to this node again, right? So what I have defined here, n dot next is equals to this node again, right? So so then what we need to write here, if this condition got failed, what I need to write here, n dot next is equal, it was null or not. So instead of null, n dot next is equals to n dot next is equals to, it should point to this new node that you have created here. Which new node that you have created with this 40? It is nothing but new node. Okay, so this is nothing but your in linked list, custom linked list. Okay, if you will add here again l dot add of 50, you will try to analyze again how this 50 got inserted based upon this code only. Okay, it will check for the head is equals to null or not. The very first head will be not null, it will be pointing to this node object. Okay, so that means your else block will be executed. In the else block, what you have defined here, you have created with the 50, let's say if you are adding the 50 means we will create another node object with the 50, and you will point this n to head node, again it will get the next node, again it will go to the next node until and unless it is not null. Once you find this null means you need to assign the next value to the new node. Okay, so this is nothing but your custom linked list, how you are going to implement. Okay, thank you everyone.